Alrighty then, we have this video on simplifying radicals when the index is greater than or equal to 2. And remember, the index right here is the number outside of the radical. We have the square root of 8. We also have the cube root of 8. So if there is no number here, that index is a 2. Let's keep that in mind too. So let's look at this first example. Simplify. I guess the direction should say simplify. So if we want to simplify this, well, what we should be thinking is going back to the square root of 8. The square root of 8 is going to be, if I break 8 down into 2 times 2 times 2, and remember there's a 2 outside there, I'm going to take 2 of those 2's, put it outside the radical, and this one right here stays inside because it doesn't have a pair. It doesn't have another number to come out with. So when there's a 2 there, or nothing at all, and that's a square root, they have to come out in pairs. Okay, well, let's look here at the cube root of 8. Cube root means, so we have 2 times 2 times 2 is 8. This number here means they have to come out in 3's. They have to come out in triplets, I guess. So then that 2 comes outside the radical, and then there's nothing under the radical, so 2 is the answer here. And so now if we change this to, like, say, a 4 or any number higher than that, they have to come out in 4's, and there's only 1, 2, 3. So you cannot simplify the 4th root of 8. That's all the further you can go with that one. So remember, the index, which is the number outside the radical, tells you how many groups, how many have to be in the group in order to pull it out outside the radical. So let's look here. 27 is 3 times 3 times 3, and x to the 5th is this. So we're taking cube root, so they got to come out in 3's. There's a pair of 3's, and there are 3 x's. Those 2, there's not enough of those x's to bring them out. So if we look here, here's a cube root. So these 3's come outside as 1, 3. These x's come outside as 1x, and these x's stay inside. And so you have just simplified there. Just simplified. There's a different way of thinking about this rather than writing it out completely like I've done there. Ideally, what you should be thinking is possibly like this. So we have the cube root, and 27 is 3 cubed, just like this. X to the 5th, you can think of it like this. X to the 3rd power times x squared, which then means that there's 3 of these to come outside, there's 3 of these to come outside, and then this stays inside. You can think of it like that. Or you can ask yourself, if I have, we already know this is 3 cubed. If I have x to the 5th power here, how many x cubes can I take out of it? Well, I can take 1x cubed out of it, and then it becomes x outside. Try to maybe think of it as like 5 divided by 3, which then gives you the 1x that comes outside, and then 2 would be the remainder, which is how many stay inside. We're going to go through a few of these examples. So we'll get a little more help here. All right, so this is fourth root, so we're trying to find them to come out in groups of 4. So if we look there, 32, what's 32 break down into? 16 times 2, and then 16 breaks down into 4 times 4, and then 4 breaks down into 2 and 2, and so this is what we have. So 32 is actually 2 to the 5th power. So we have 2 to the 5th power and y to the 4th power. We'll go take the 4th root of it. Okay, well, how many out of 2 to the 5th, how many groups of 4 2's can I pull out? If we look here, there are 4 2's right there, leaving 1 left inside. So if we leave the 1 2 inside, and then the 4 2's come outside, the 4 2's come outside as 1 2. And then the same thing here. How many groups of 4 y's being multiplied together can I pull outside? That would be 1, because there's y to the 4th power. That means there's 4 of them there. Think about it like this. 5 divided by 4 would be 1, 2 to the 1st power. And then there's a remainder of 1, which that one remains inside under the radical. 4 divided by 4 is 1, and that's where a number comes outside, and then the remainder stays inside, but in this case there's no remainder. So your final simplification here should be 2y outside, and then the 4th root of 2, 2y to the 2y times the 4th root of 2. There you go. This is a square root of 8, x to the 8th and y to the 9th. See if you can try this one on your own, see what you can come up with, and then check your solution with mine. Remember, it's square root, so there should be a 2 there. Square root of 8, I'm thinking this is 2 to the 3rd power. 8, here we go. And so divide by 2, because that is the root that we're looking at. And so when I do that, right here, 3 divided by 2 means there's 1. And then what's the remainder? 1. There's 1 left inside. So there's 1 that you pull out, and then 1 left inside. How about the x's? 8 divided by 2, that would be 8 divided by 2 is 4, so you're actually bringing them out, and 4 of them out. 4 pairs will come outside of the radical. And then 9 divided by 2, well, you can bring out 4 pairs, but in this case there's going to be a remainder of 1 left over. A remainder of 1 left over. And so this is the simplified version of that. Simplified version. And example 4 here. Let's have you try this one on your own, see what you can come up with. Hit play when you're finished and check it. 72. 72 is going to be 36 and 2. And this is actually 9 and 4. And I'm looking for cube root. So right now I know that this right here, 4 times 2, is actually 2 to the 3rd power. And 9 is going to be 3 squared. Okay. So we have 3 squared, 2 to the 3rd power, a to the 10th, and y to the 17th. And what comes outside? 3 squared does not, because there's only 2 of them being multiplied, so they stay inside. And what about 2 cubed? Yes, there's a group of 3 2's that you can pull out, and when you pull them out, let me get a different color here. When you pull them out, they become 1 2. Okay, so we've dealt with this one, and 3 squared is 9. I'm going to go ahead and change it back to a 9. So we've dealt with this one, and now 10 divided by 3. Well, 10 divided by 3 is 3 1/3, so there's the 3, and the remainder was 1. So we've dealt with this. And then 17 divided by 3. 17 divided by 3 is 5 2/3, so there's the 5. And what's the remainder? 5 2/3, the remainder would have been 2. And so there's the simplified form of this. Alrighty, man, we're moving right along. How about this one? You can try this one here and see what you can come up with. Uh, 320. Well, if you know that 2 to the 5th power is 32, you'll want to go 32 times 10, and then this just becomes 2 to the 5th power. And this, I know this is 2 times 5, but really, I mean, we're talking about cube root of 5. Or, I'm sorry, not cube root, we're talking about a 5th root. So this is the number we're looking for. These two will just go ahead and get multiplied back into becoming 10 by the end of the day. So we have a 5th root here. We have 2 to the 5th power and 10. I'm just going to go ahead and put 2 times 5 back as 10. And m to the 22nd, n to the 3rd, and p to the 12th. And let's see what we can bring outside here. Of course, we know 2 to the 5th power will come out as a 2, because there are 5 of them, so they come out as 1, 2. 10 is just 2 times 5. There's no groups of 5 of anything in there that we could pull out. So we've dealt with this one also. M to the 22nd. Well, since it's 5th root, 22 divided by 5, that will be m to the 4th power, or 22 divided by 5 is 4 2/5. So m to the 4th power outside, there was a remainder of 2. N to the 3rd power, or sorry, the 5th root of n to the 3rd power, you can't pull anything out because, 3 divided by 5 is just, we'll have a remainder of 3. And then p to the 12th power here, how many times is 5 going to 12? That would be p to the 2nd power, and what is the remainder? The remainder is 2. So yeah, there we go. We've just simplified that one. So that's what we're working with. That would be simplifying radicals when the index is greater than or equal to 2.